Thanks for coming out. I'm Jeff Hoffman. I'm the director of the AWS Elastic Beanstalk team. With me is Adhiraj Singh. He's a senior product manager, also with Beanstalk. And we're here to talk to you today about scaling web applications with AWS Elastic Beanstalk. Let's talk a little bit about what we're going to cover today. I'm going to start with an introduction. For those of you who are already familiar with Beanstalk, I'll go through this at a reasonably high level, but I don't want to leave anybody behind. I want to make sure we level set and everybody gets a good understanding of what we do and what we're for. So we'll talk about that. We'll talk about how you would use Beanstalk in favor of what I call DIY. In this case, when I mean do-it-yourself, I mean still with AWS. I'm not talking about making your own servers and racking and mounting things. So it's still going to be what Beanstalk does versus what you could do yourself with all of the same services within AWS. We'll talk a little bit about how you get started with Beanstalk. That should be, again, pretty simple and straightforward. And then I'm going to turn it over to Adhiraj, and he's going to actually show us a working demo of a somewhat complex, but not crazy complex, Beanstalk app. And he's going to use that as a springboard to go through a whole host of best practices. And that actually is probably going to be the meat of our discussion today. So why did we make Beanstalk? We really wanted to address what we saw as, in the market as a host of challenges for customers. So you can see that we believe one of the things that customers deal with a lot is either complexity, or for those of you who are feeling kind of a little more sophisticated, have done this a lot, the kind of repetitiveness of deploying code, provisioning and managing infrastructure every time you want to do something with a web app. The expertise or time, again, on that spectrum of how sophisticated you feel, like to actually manage and configure all of the infrastructure that goes into hosting a web app, how to actually do auto-scaling or manage the scaling of the infrastructure itself. And then even if you master all of that, even if you've got that all down, if you're a big organization, you don't want to have to relearn those lessons. You don't want to do it differently for each team that's going to have to go through these same steps. So consistency across team is something else that we wanted to address. What is Elastic Beanstalk? For those of you who've never seen this before, we think of it as the easiest way to deploy and manage web services of any kind in AWS. That's our goal. So it doesn't do anything magical that you couldn't do with AWS any other way. Well, maybe it's a little bit magical. But it's all open. You can actually figure out everything that we're doing and extend it. And we'll talk a little bit about that as we go. What do you manage within AWS Elastic Beanstalk versus doing this all yourself? That top little box is your code. Our goal, if we do it right, is that at least on an ongoing basis, that's the only piece that you worry about with Elastic Beanstalk. We take care of for you, once you choose what we think of as kind of a supported platform, everything else that's below that box. So we handle the HTTP server, the app server, the language interpreter, if there is one for that language, the OS, and then of course underneath that there's still the same infrastructure you're used to from EC2. There's a host. All of that stuff is managed as part of what Beanstalk will do for you. If we zoom out one level from that, there's actually another layer of kind of management that we do. So beyond just the stack that's running your code, there's a whole host of other infrastructure pieces that you would expect to want for any kind of a well-provisioned app. So we have a couple different options as to how we'll let you deploy. You can either do a single instance. We'll talk about what that means. It's great for kind of dev test or low cost, if you don't want to do a lot with load balancers or auto scaling. And then we have a more production-centric kind of mode of operating where we'll offer load balancing options for you. We'll set up auto scaling for you. We do offer both a web and a worker tier. I'll talk a little bit more about what that means in a minute. And then you can see kind of this example of some of the infrastructure we might stand up for you, including all the way through to RDS databases at the back. That doesn't have to be the way that your infrastructure looks. It's actually very flexible. You can choose a lot of very cool, like under the covers kind of configuration things with something called EB extensions, which I'll only tease you about right now, and let Adhiraj show you a little bit more about that later. And we even do all of this through to providing a domain for you, actually give you a CNAME that's unique to your app. Of course, if you have your own, most people do when they get to a production level, you can provide that as well, and we'll manage that with it. So what you're going to get from this, we hope, is a very easy to start with process for those of you who just want to kind of experiment, or if you're in dev test mode, or you really are intimidated by the variety of things that you can do with AWS. This is still the way that I think is the easiest to get started, with our eye on making the developers as productive and agile as we possibly can. But our goal really is to be impossible to outgrow. We don't want this to ever be a service that we think of as the kind of for the kind of low end of the spectrum. That's not our goal. And so to that end, we provide you complete control over your resources. Even though we make it easy to get started, you can actually reach into the way that Beanstalk does management of infrastructure. And again, we'll tease you a little bit with that later on. That note at the bottom is also important. There's no additional cost for using AWS Beanstalk. That's only the resources that we're provisioning on your behalf that you're paying for. This is a service that we provide on top of that for free. So what do people use us for? As you kind of guessed from my language so far, it's mostly a lot of web applications, it's websites, it's API backends, it's mobile backends, but we do have the support for kind of a worker model, asynchronous workers, and we'll show a little bit how you choose that in a minute. How do you get started with it? That's a great question that I asked myself. So this is all you need. You need to provide your code and then answer a few kind of questions. You decide exactly how you want to walk through the process of standing up your application. You pick a region. We're in every public region. Beanstalk is among the very first to deploy, so as the regions grow, we hope to always be there near launch. You pick what we call here a stack type or a container type, and you can see the supported platforms on the right. We support Java, both in Tomcat mode and a native just raw Java container, Node, PHP, .NET with IIS, Python, Ruby, and Go. And you'll notice Docker nested in the middle there. If you want some kind of control beyond any of our very prescribed stacks, you can choose either a single kind of what we think of as like a native Docker instance where we push out a container that just has support for Docker, and that's the only assumption we make. Everything else you add to it is up to you. Or we have integration with ECS. You can actually do multi-container kind of deployments through a Docker interface all the way to ECS as the backend. You choose whether you want to do a single instance or a load-balanced, auto-scaled kind of environment. And again, the decision there is really what's my trade-off between cost and speed of deploying this thing versus stability, kind of reliability. That's the thing that you get with a load-balanced, auto-scaled environment. And then you'll notice I have an optional RDS piece at the bottom. It's actually pretty easy from our interface to say, as I stand up this application infrastructure, go ahead and create an RDS database for me as well. That's great if you're doing dev test, but I want to give you a caveat on that. The lifecycle of the RDS database that you create this way, in this example, is tied to the lifecycle of that environment that you're creating. So again, great for dev test, where you want to stand up a set of data to test against and then tear it down when you throw that version away. Not great if that's what you're trying to do for production data. We do have ways, obviously, to tie into other production data environments, whether it's RDS, Dynamo, or pretty much anything that you can think of behind the scenes. We can actually offer a way to integrate that into a Beanstalk environment. So some basic terminology that'll help you understand kind of the rest of what we talk about. Everything within Elastic Beanstalk starts with an application. And that's just a generic way of grouping together a whole host of deployed versions of a single app. And when you create an application, the first time you upload any code to us, the first time you provide us something to deploy, you name it. You pick an application version for that. And it doesn't have to be V1, V2. It can be anything that you want it to be. You can actually name it based off of a Git branch. You can do whatever you want with it. And that flows directly into any number of environments that you have. The cool thing is each environment, and really we're not very opinionated about what you use your environments for, but you can imagine a typical use case is dev, test, staging, prod, something like that. Each one of those versions are independently deployed to each of those environments. And the coolest thing of all is that you can say, okay, when this is tested and proven, let's say in integration testing, I can take that exact same deployed application version by name and move it into prod. You don't re-upload anything. There's no chance to incorporate untested changes. It just moves that one into another environment for you. And I say move, but it doesn't even have to move. It can actually be copied. So you can have the same environment versions running, or application versions running in multiple environments if you want. How do you deploy them? Let's take a look. There's a lot of methods. You can do it through our console. We have a full web console, as you would expect for any AWS service. We also have toolkits for Eclipse and Visual Studio. So if you want to, you can do deploys directly from your IDE. Again, really helpful for fast turn kind of iterations within dev test cycle. We have, obviously, support in the AWS SDK and the AWS CLI. So if you want to automate some of this stuff, or if you have kind of a pipeline that you want to bake into a EB deploy, you certainly can. But we also have our own CLI. And the EB CLI is what I'm going to show you a little bit of. You'll actually see a glimpse of it a little bit when Adiraj does his demo as well. It's very rich, and we're going to walk through a little bit of what you get with that in just a second. But any of these things will do the same kind of work under the covers. So again, I mentioned we'll do a little run through here of what you can do with the CLI, with our EB CLI, including how to install it. Very easy to get started. You can also just download it if you want to. You don't have to do a pip install. We assume in this case you're going to start with some kind of a cloned sample app, but again, it could be your own code. You can start with something that you already had in Git or whatever repository you want. You'll see on number 3 there, we're doing an EB init. What this does is like an interactive session of walking you through all of those decisions I talked about 3 or 4 slides ago. So it says, tell me which region you want. Name this application. Tell me whether it's single instance or if it's load balanced, auto-scaled. And once that's all done, once you've walked through those steps, it actually does the deploy for you. When you say EB create, you're off and running. And then from that point, let's say you want to iterate on this, as you would, you can continually go in a cycle of updating your code, committing your changes, and it could be as simple as saying EB deploy. And by default, we pull the latest committed change, and we deploy it with the same name that you've given that commit. Again, you can override any of this. The EB CLI is very rich. I encourage you, there's links at the end of this that will go into more detail for everything that we're covering, including what Adiraj is going to get to later. But the EB CLI offers a lot of additional kind of command line switches that you can put in there to kind of tailor exactly what you wanted it to do. We even give you a shortcut to just hop straight to a browser session with whatever CNAME we've set aside for that deployed app. So having said that, what we're going to walk through next is the sample app that shows everything kind of that I've described, but it takes it one step further. And what we're going to do is talk about how to take kind of the basics of what EB can do and then tailor it, configure it, or customize it a little bit more. So again, I mentioned before this concept called EB extensions. That's a way for us to kind of plumb through additional AWS resources in a way that it makes very easy for your code to consume references to those resources without having to hard code anything. So you get a glimpse of that when Adiraj shows that sample app. In this case, we're going to show how to tie in a DynamoDB, SNS, and SQS. So we're going well beyond what the kind of initial sample app might have done. And with that, I'll turn it over to Adiraj.
Thank you. Thank you, Jeff. So to avoid any network issues, I created a video for the sample app. This is essentially a launch pre-sign-up app which is built in Node. The application, let me activate this. It's already running. OK. So the application stores data in so essentially, the customer would come in and they would give in their name and their email address, and it would sign them up. This data would be stored in Amazon DynamoDB and publish notifications to Amazon Simple Notification Service when a customer fills in the form. The sample application is using an Express framework and Bootstrap to build the simple application. Now, let's look at some of the application components which this application is using. Let's give it a second. OK. So if you see here, this is the sample application. These are all the subfolders and the files in it. First thing to define is the dependencies of an application user. We use standard dependency frameworks. This is a Node app. So if you see here, you would have the dependencies. You should not, it is highly recommended that you do not use latest. You should hard code your dependencies. Here we are using shrinkwrap.json which essentially is a dependency manager file for node applications. This locks down, excuse me. This locks down the version of package dependencies so that you can control exactly which version of a dependency will be used when a package is installed. So by default, npm recursively installs target dependencies. Now let's look at the EB extensions that Jeff mentioned. EB extension is a great framework which you can use to modify and customize the applications or configuration stack. Configuration files are YAML format documents with a .conf file extension that you place in a folder named EB extension, as you can see, in your application source bundle. Two of the most important components of EB extensions are option settings and resources. Now let's look at the option settings. You could configure, so this helps you to configure different options. In this case, we are configuring two tables. One is startups sign up table, and other is the new sign up topic. It is also recommended that you use reference and avoid hard coding in these files. Another section is the resource configurations. I'm defining create DynamoDB table and a create SNS topic. So which is essentially what's going to do is whenever someone signs up, the admin is going to get an email based on those notifications. In addition to that, this has an IAM policy defined. You have to create an IAM instance profile name. I named it AWS Elastic Beanstalk sample role with the policy which has been defined in this file. This allows EB to communicate with DynamoDB and SNS service on behalf of the customer. I'll be using EB CLI for this. So I used EBINET. Sorry, it was a little quick. When you do an EBINET, it will ask for different options. You select the right region. I selected one, that is Virginia. And then I selected an application. I wanted to create my own, so I created a sample app 1. It is going to create a sample application, and it will ask you for the platform version. And if you see here, I'll probably pause it. If you look here, we have recently added support for code commit, where you can store your repositories and store your code. So I have 4 repos. I'm using reinvent. So if you see, I'm choosing master for the branch, and the SNS, SSN, and the key pair. Oops. OK. So I choose the repository. There I have the sample application, and I give other information related to branch and the SSH, sorry, and the key pair. OK. Now, once this has been done, all my initialization is done. So I can now go ahead and create an application. For that, I will use an EB create. Hopefully, it will come up. OK, perfect. So I'm using an EB create. I'm using an instance profile that we just discussed. And once you initiate this, we will start creating, Elastic Beanstalk will start creating an application version with this instance profile, giving us the capability of interacting with DynamoDB and the SNS. If you see, it's asked for the default. I choose all the default options for the CNAME. I use the classic load balancer, and it will start creating the application for you. Now, just to quickly get to the end of it, I have fast forwarded it, and we have, you can see the application getting deployed on Elastic Beanstalk through the console. If you see, this is a dashboard. The dashboard would have the status, the recent events, the running, and the node, that kind of application that is running. And there is a URL. If you click on the URL, it will take you to the application that we just deployed, and you can quickly test it. You can put in the information of the name and the email address. And let's quickly check what happened here. So this is the DynamoDB table that we created. DynamoDB table named the startup signup table. It has this entry. And same would be for the SNS topic that was created. OK, so this was a quick run through our sample app. Now I'll cover the biggest section of our presentation, which is referring to the best practices that we recommend for using Elastic Beanstalk. We have many deployment options and managed platform updates that was recently launched. I will touch upon auto-scaling and some reference to load testing and other smaller tips. So we recently, I'll give it a minute for you to absorb this slide. Essentially, we provide different options for deploying your application or your platform configuration. It is based on either you have a single instance environment or a load balance and autoscale instance, autoscale environment. Based on if it is an application deployment or a platform configuration deployment, you have different options. If you see Immutable in single instances, they have been recently added. In fact, last week, we launched Immutable deployments for single instance. And we'll discuss some of these options going forward. Now let's discuss all at once. EB deploys the new version of all instances simultaneously. So all instances in your environment are out of service for a short time while the deployment occurs. By default, the environment uses all at once deployment if you create it with a different client like API, SDK, or EBCLI. If you see here, the instances are getting updated to version V2, and V2 is successfully deployed, and your application is up and running. Now let's discuss about rolling. Rolling, this essentially deploys the new version in batches. Each batch is taken out of service within these instances during a deployment phase, which reduces your environment capacity to a number of instances in the batch. So if you see here, so you can define the batch size by the number of instances or the percentage. So here, let's say it is 50 or 2 based on percentage or numbers. We take these down, we deploy V2 to these 2 instances, and they come up. By default, your load balance and autoscaling environment uses rolling for application deployment if you create it with the console or the EBCLI. If you see here, then the next 2 instances which were not updated, they are updated, and it's available. So one of the biggest downside of using rolling is that if you are running traffic on this application, your capacity would be reduced because you're taking some of the instances down within the instances that you have in that environment. Now let's talk about rolling with additional batches, which solves some of these problems. Rolling deployment with batches deploys the new version in batches, but first they launch new set of instances based on the batch size that you have defined. If you see here, we launched, let's say you have defined as batch size 2 or 50%, it will launch 2 new instances which are getting deployed with version 2. And once they're up, the traffic is routed to them. So at this instance, you would have a little higher capacity. At that moment, once they are up, we bring 2 of the existing instances down and bring them up with a new version of application, and we bring it up. And once we already have V2s on 4 instances, that was the original batch size, we take down the rest of the 2 instances that were already there. So this essentially is the final look that you update. Now let's look at Immutable. So Immutable, in Immutable, this essentially even the issue of turning down the existing instances is also taken care of. So Immutable gives you new instances altogether. In fact, it creates a completely altogether a new autoscaling group. Though it's temporary, once the instances are up and running, the traffic is diverted to the autoscaling group, the new autoscaling group, and the previous one is taken down. So with the first instance pass, if they pass, so there are two steps essentially. So first we bring one instance within that autoscaling group, and once that is successful in our health checks, then we go ahead and add other instances, which essentially replicates your capacity in your application. So during immutable environment update, the capacity of the environment doubles for a short time when the instances in the new autoscaling group start serving requests and before the original autoscaling group instances are terminated. If your environment has many instances with a low on-demand limit, ensure that you have enough capacity to perform the immutable environment update. If you are nearing a limit, service limit, consider using rolling update instead. Immutable update requires enhanced health reporting to evaluate your health or your application's health. So if, like you see here, it will take down the autoscaling group, which was already there, and you have a completely new autoscaling group with new instances. This has a lot of advantages of your rolling with batches, because it completely eliminates the possibility of any issues during deployment. If the deployment doesn't work, it can quickly roll back by taking down the new autoscaling group, which was temporary anyway, and it reverts back to the previous autoscaling. Now, let's look at blue-green. So we have a DNS-based blue-green option for you in case you want to ensure that your application should not have any downtime at all. This is the best way for doing, but it requires some manual steps. Just because Elastic Beanstalk performs an in-place update for your application versions, your application may become unavailable for users for a short time. So what we do in blue-green is you have an existing environment with this autoscaling group. You go ahead, this is a snippet from the console. You go ahead and click on Actions, do a clone. So Elastic Beanstalk will create a clone environment for this current environment that you have, and will give it a new name. You have to give a new name to it so that it can distinguish. So once you have this new cloned environment available, you go ahead and on the new environment, you go ahead and click on Actions and do a swap environment URL. And you would have the screen. You can select which environment you want to swap in terms of the URL. And once you do that, the URLs are swapped. So, I missed one thing which I should point here. So you have to manually update this new environment with the new versions, the V2 version that you have. So once that is available and the health checks are passed, then you can go ahead and do the swap. So essentially, you don't have any downtime. So you swap this, and as you can see, the old URL you can continue to use, and you have the latest versions of applications deployed on the instances. So what are the pros? The pros are fast rollback, because the previous environment is still running. So if it doesn't work, then you can always switch back. And the cons are it's slow, because you have to create a new environment altogether, so it takes a little longer. And there is a potential of DNS caching by mobile clients after CNAME swaps. So this slide essentially summarizes different deployment options, application deployment options, if I may emphasize. So some of these are also used for configuration, but we have a brand new option for you to use application configuration deployments. Let's discuss about these options here. If you see in the column impact on failed deployments, all at once has expected downtime. Rolling would have downtime, but again, it would be based on error scenarios. On rolling with additional batches, it is really minimized, especially if the first batch fails. Otherwise, it can have issues. If the subsequent batches have issues, then it could have problems during deployment. And Immutable, it minimizes your downtime, and blue-green has no downtime altogether, but I still use minimum because things can go wrong. In terms of deployment time, as you can see, all at once is the fastest. Blue-green takes the longest. Rolling with additional batches it's essentially based on the size of the instances and the environment complexity. Based on that, it will take higher amount of time. In terms of rollback, if you have to roll back if anything goes wrong in any of these scenarios, most of the scenarios you have to do a redeploy. Only in blue-green you can essentially do a swap back of the URL. And if you see all at once rolling, it uses existing instances. So the probability of something going wrong could be higher. In terms of rolling with additional batches and immutable, we use new instances, but immutable, it uses altogether new instances. Blue-green, again, it's a totally a new environment. Now let's look at managed platform updates. Earlier this year, we launched managed platform updates, which is essentially giving you the ability to configure your environments to automatically upgrade to the latest version of a platform during a scheduled maintenance window. So until recently, you needed to initiate a managed update to update your application Elastic Beanstalk environment to the new version of the platform. So managed platform updates gives you the ability to configure your environment to automatically upgrade to the latest version. Some of the key components to know about this functionality is that you still need the permissions. Elastic Beanstalk needs to initiate a platform update on your behalf. So you use the default service role. So the console adds the required permissions when you enable manage updates. If you don't use the default service role, you can manually go ahead and do that. Maintenance window. So maintenance windows are essentially 2 hours long. Elastic Beanstalk starts the schedule update during the maintenance window, but the update might not complete until during that time. So this is our best guess that it would take. It generally takes about 20-25 minutes, or could be less based on the complexity of your environment. But if it's taking more than 2 hours, then there's something wrong. What kind of deployments that we do? You can configure your environment to automatically apply patch version updates or both patch or minor version updates. Managed platform updates don't support major version updates as of yet, which may be introduced later. Let's look at some of the key benefits. Now, so we talked about automated upgrades. This essentially gives you the free hand to schedule it and forget about it because we keep on adding new features, updates to the environment and the configurations, so you don't have to worry about being at the latest versions. With the managed update, we ensure that the application remains in service during update process with no reduction in capacity. So because essentially underneath it's using immutable deployments, so this gives you the complete capacity of your application. So very good for even your production environments. If for any reason the update is unsuccessful, the platform is rolled back to the previous version without impacting the capacity. So one thing which is good about managed platform updates is that we ensure that your application is always up and running. So even if the update doesn't happen, we roll it back and to the previous version that you have. So as I discussed, there's minimum downtime, and the impact on capacity is also minimized. You also have the flexibility of manually updating. So you have scheduled it, but if you realize that your application has an unscheduled downtime or you want to update it, you can still do it using manage update. And it also gives you the flexibility of doing an instance replacement. What that means is when you schedule a manage update, you can select an option of instance replacement. So even if when there is no available update, you can still refresh your instances, essentially have new set of instances. So this gives you a lot of flexibility in terms of refreshing your fleet every now and then. Although some of the important things I would like to know that is part of the best practices, you've got to be careful about coordinating manage updates with time-based scaling. If you're using time-based scaling, the number of instances are 0. We'll talk about time-based scaling later in the next section. So you have to be a little careful that managed updates should not conflict with time-based scaling. In terms of service limits, the managed updates are immutable deployments. So it is recommended not to schedule managed update for multiple environments at the same time, because you may end up running into your service limits, especially auto-scaling groups. All right, I have a small demo for manage updates. It's again a video, just to save time and not to rely on the network. So this is a single instance environment. This is a single instance environment. So if you see the configuration, it says that there is a new version available. So I don't want to go ahead and do the change. I want to schedule it. I want to automate this process. So you enable manage updates. How do you do that? You go ahead and click on configuration, go to manage updates, enable, and you can define a window, a starting window. End is essentially 2 hours, so you don't need to define the end. So we'll start at the start of this window that you have defined. You can choose a starting time or a date. So this essentially would start doing it every week at this time. And if you see, there are update level, minor or patch, which you can define what kind of updates you want to actually deploy automatically. And then you have the option of instance replacement, which we discussed, that even if there is no updates, you can still go ahead and refresh the instances that you already have, or essentially get a new fleet of instances. So I'll go ahead and apply. So this takes a few minutes to configure. So if you see, it will at the top, it would say Elastic Beanstalk is updating your environment. And you can look at the, so that's the benefit of using a video. So, so you can see I clicked on the manage action. So manage updates had been scheduled, but because it has been scheduled next week, so what I'll do now is I'll do an apply now using manage update. So it will still consider it as a manage update and use underneath immutable deployment. Let's do an apply now. OK, so this you get a confirmation and tells you about more information if you want to know, and it tells you about from what platform version to what platform version we are going to. So if you do a deploy, it will go ahead and it takes a few seconds to configure and start the deployment. So it will do the deployment, and so if you see, you can always see the recent events at the dashboard, or also there is an event tab. Now, if you see here, the configuration has been updated. And if you go to manage update, it will tell you the timestamp, the duration that it took, what took about 14 minutes, and the platform version to what, and it was completed, success. So this was a successful video. OK. All right, now let's talk about autoscaling. So autoscaling is a web service designed to automatically launch or terminate EC2 instances in an autoscaling group based on parameters that you define. This helps you to seamlessly deal with traffic changes to your application. Elastic Beanstalk supports autoscaling for load-balanced autoscaling environments. If you see at the start of the tree, or the root of the tree, you have few default configuration elements: minimum, maximum instances, availability zone, scaling, cooldown. So autoscaling works with CloudWatch to retrieve the matrix for the instances running our application and also monitor the health of each instance. So the minimum instance count and the maximum instance counts is essentially you define the size of your autoscaling group. So at what moment of time you want to have what instances, you can control it by an upper limit and a lower limit. To maintain a fixed number of EC2 instance, you can also have same number of minimum and maximum. This ensures that you have a consistent number of instances, but again, that's not autoscaling. Autoscaling settings can impact rolling updates. If you configure rolling updates, and rolling updates cannot happen if the minimum number of instances in service for rolling updates is larger than the maximum size of the autoscaling group. So you must change the value of either the minimum instance in the service settings of the rolling updates or the maximum instances. Then you have the availability zone. So that lets you specify the number of availability zones in which you want Elastic Beanstalk to launch your instances. We highly recommend that you choose multiple availability zones so that instances can be launched in another AZ if one zone becomes unavailable, which makes your application fault tolerant. And the scaling cooldown specifies how long the autoscaling will wait before resuming any scaling activity. So if by the time the cooldown period elapses, your environment has the appropriate level of resources to keep the CloudWatch alarm from continuing to fire the new instances. Now let's talk about trigger-based scaling. Now, trigger, as the very name suggests, you can define the triggers for the autoscaling to happen. Some of them has been noted here, like CPU utilization, network traffic, disk activity, or instance health. So Amazon, so you can configure these triggers to fire an EC2 instance or the load balance matrix, and it is pushed to Amazon CloudWatch, and it determines whether the condition you specified have been met or not. When the upper and the lower thresholds of the conditions for the matrix have been breached for the specific period of time, the trigger launches a scaling activity. So you can choose the trigger measurement. So trigger measurement setting is essentially to specify the matrix for your triggers, as we discussed. So there is trigger statistics. So trigger statistics is the minimum, maximum, or the average. What do you want to use as a measurement? You want to use an average of the data or the sum or minimum, maximum. So measurement period specifies how frequently the Amazon CloudWatch measures the matrix for the trigger. Default is essentially generally 5 minutes. Then there is breach duration, is the amount of time a matrix can extend beyond its defined limit. Upper and lower breach scale increments specify how many Amazon EC2 instances to add or remove when performing a scaling activity. Default is 1 and -1. You would notice that there is a dotted line between time-based scaling and the basic configuration. That's because time-based scaling overrides the basic configuration settings that you have for auto-scaling. So if your Elastic Beanstalk application has predictable needs for scaling, then you can use time-based scaling. It is not recommended when you're not sure about the kind of traffic that your application is taking. If you are very sure that, okay, your application is generally used over the weekend, or it's a test environment where you are sure of the kind of scaling needs that you have, time-based scaling is a good option. So if you see the different option settings that we have, of course, the name and minimum, maximum instances. This essentially overrides the default configuration that you may have in the basic auto-scaling. And that's where it can also conflict with manage updates, because if you define minimum as 0, you can define minimum as 0, that at certain point you can actually reduce the number of instances to 0, saving you money. At that moment, managed update will not happen because it needs instances to be able to continue. So that you need to be able to understand some of the dependencies there. In addition to that, occurrence. So if it is time, you need to define the time frame or the starting point of the time-based scaling. You can choose a one-time or a recurrent. One-time could be you can define a specific duration of the day, month, or week, and from there on it will do the action, one-time action that you defined in the time-based scaling. Or you can do a recurring. Recurring can be weekly, monthly. You can define the frequency. In the recurring, you can define it as a cron expression. Like here we have it's 38*3, which is essentially Wednesday at 8:30 p.m. One note of advice, be careful with time-based scaling, because it can, as I told, it can conflict with other auto-scaling configurations. So it is not recommended to use both simultaneously unless you are doing some tests. These are some of the other tips that I have for you. You should always enable log rotation to automatically push logs to S3. This saves you the hassle of looking for logs, and you have a store location where you can extract the logs that you want to use. It's also advisable to understand the available metrics for the environments and what they mean, so that you can use them wisely, like in case of autoscaling and other CloudWatch-related logs. Also, I recommend using alarms to automatically monitor critical metrics and send notifications when the matrix is out of normal operating range. So you can always set an email notification for yourself. And also enable Amazon Route 3 health check and alarms. Another important feature is tagging. If you don't know what tagging is, it essentially is a way of managing your resources, or at least tracking them. You can also track the usage of those resources in terms of the number of people that they may be using, that are being used by those people, or it could be in terms of the financial impact that those resources have. So you can use the cost allocated reports to track the usage for AWS resources. The reports include both tagging and untagging resources, but they aggregate cost according to the tags. Elastic Beanstalk recently updated the number of tags that you can use from 7 to 47. 3 of them are retained by us, which includes environment name and environment ID.
Can you go back one slide? All right. Add a little bit of color here. So just to kind of, these feel like very disparate, almost random, like best practices when they're presented this way. But I want to give you one example by like kind of weaving one thread through everything that Adiraj has walked through, just to give you a sense of how these can be interconnected, why it's important to really keep all of these kinds of things in mind. So let's take the example early on in the sample app. Adiraj was showing you that he had a not best practice, kind of something to avoid in the first example of how he was not pinning versions in his Node app. And he mentioned, correctly, don't do this. And he talked a little bit about how it's better to kind of like bake the versions in. In that case, he was using shrink wrap, but there's really equivalents in other language platforms too. Take that example, and then now imagine what happens if you don't do that when you couple it with some of the other deployment methodologies that we looked at, in particular if you're doing managed platform updates. So think about how, let's say I'm migrating a minor version or even a patch level version of Node, the Node platform. Should be relatively safe, should be relatively low impact. But I've always said, draw the latest version of all my dependencies. Middle of your kind of defined window of time, in the middle of the night sometime, we deploy the new version, and it pulls latest versions of dependencies down. You've not tested those combinations, and maybe not surprisingly, you actually have something that breaks. You can see why that would be a problem. Now think about how in managed platform update, I don't know if you maybe mentioned this in there, but managed platform updates always uses the immutable deploy technique, the one that we went through that showed creating an entire second autoscaling group and making sure that we do kind of almost like a one-box deploy within that autoscaling group. We watch the health of that run. There's a reason we do it that way, and there's a reason we don't even let you override that. In even those cases, we test that one box, make sure that it actually appears to be running healthfully. And the way we do that, we haven't talked too much about our enhanced health feature, but we actually watch for traffic flowing, watch the return codes that were resulting from that. So if the app is throwing 500s, we're actually going to abandon any attempts to deploy. Not only that, but all of your original version is still running. We leave those completely alone. So we actually just tear down that one box, and you're left with kind of the original capacity and the original service version still intact. It gives you a sense of kind of how there's like connections between some of these best practices that may not be apparent right up front. I'll also mention another one. I don't know if this was in here, but you never, ever, ever bake state into your instances. This is, by the way, not a Beanstalk best practice. This is kind of a cloud best practice. If you are doing something with local file systems, if you're counting on something that exists within instances that you've deployed, you're going to want to spend some serious minutes thinking about why that is and how you might want to avoid that. And we actually put in, again in the Managed Platform Update, that you saw there's a checkbox to allow for instance refresh. And basically on every scheduled window, whether or not there's a platform update, we'll let you kind of wipe through the entire set of recorded instances. We're basically offering you a way to guarantee that you're not building up state on those instances. Again, best practice, and it actually has repercussions throughout all of these things. If you're counting on state, if you're counting on a variable, or if you're not counting on a fixed version, you might even have problems outside of managed platform updates. Let's say you have an auto-scaling event. You're going to pull up the latest versions of whatever dependencies you might have for, let's say, your Node app. So again, a lot of these best practices kind of you want to think of as like and you're weaving them throughout your planning of your architecture. It's not I like that one, so I'll do that, but I don't care about this other one, so I'm not going to do it. Not to say you can't have success if you don't follow every one of these, but you should at least be considering a lot of these things as part of the total story. So, go ahead.
So this essentially brings us to the end of the session. Here are some of the key links which were referred to during the session, which includes the resources for sample application, deployment options, manage updates. We did not cover load testing because of lack of time, but I have some sample links which you can use for using Locust for load testing with Elastic Beanstalk, and some information regarding tagging.
Well, I'll say one other thing before we finish too. We will have
repeats
throughout the week. We're going to be at the expo floor. You can find sometimes Audra, sometimes other members of my team there. So if you have questions, certainly stop by the AWS booth there and ask us questions. We have a repeat of this session Thursday?
Thursday, 2 o'clock.
I don't know, what else should we mention? I guess that's probably good. So the versions of this presentation will be made available to everybody, so you'll be able to kind of get these links in the easy way. Click on them instead of try to copy them all down. Thanks everybody for coming. Really appreciate your time.